Welcome back to task 6. Now we want to code the plot results function. So plot results is going to take a number list and then a variable that says either all, trailing or leading, and we want to create a dictionary of numbers. So we start with an empty dictionary, and then if, maybe close this here, right? So if digits is equal to all, then what we're going to do is we're going to loop through the number list for number in number list. And now we want to go through all the digits of each number. Now, going to the digits of an integer or a float number is not so easy. It's much easier to go through a string of a number, right? Because if we loop through a string, for example, if we loop through the string 3.4, then first we get the 3, then we get the plus, dot, and then we get the 4. So that would be the much easier way to handle this. So it's easier, it's easier to turn this number into a string. So that's what we're going to do. And then we're going to loop through this string. So for digit in string of that number. And then if this digit is already a key in the dictionary, number dict keys, if it's already in this, then we're just going to increase the counter of the digit plus equals 1 by 1. And if not, if it's not already in the dictionary, then we make sure that the digit is in 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's one of the numbers that we actually want to count. So we don't want the 0, and we don't want to count dots or commas. If this is the case, then we add this key to the dictionary and set the counter to 1. Digit equals 1. All right, so let's test whether this is working. Return number dict. All right, we have some list of numbers here already, so let's run this. And of course, we need to run it with all, because otherwise we haven't really done much yet. All right, so this looks good, right? So we have 9,000 something something ones, 4,000 nines, and so on and so on. Okay, so it's working. All right, let's return to our function. Now for the leading digits, we're going to do pretty much the same. So if digits is equal to leading, then again we're going to loop through the number list. We're going to turn the number into a string to make it easier to loop through. And then if we have found a number that is either already in the dictionary or we have added a new digit to the dictionary, then we have to stop because we're only interested in the leading ones. So we want to break out of this loop and then continue to the next number. So we run just the break command here. This will break us out of the loop. And then now for the trailing numbers, so trailing, again, we're going to do pretty much the same. Again, there are different ways to go about this. We could loop through the string of number here in a backwards way, but the easiest way is just to reverse this string, right? So we'll just reverse it by slicing it. So starting value, end value, we don't set those, and then order -1. So this just turns this string around, and then what used to be the trailing number is now the leading number, and everything else is pretty much the same. So let's quickly see if this is working. So leading, right? So, and then trailing, we should get trailing, so we get some other numbers here. All right, so now we want to plot this. So it might be a good idea to, you see the dictionary here is kind of unordered, right? Depending on in what order the trailing and leading digits and everything here appears. So we just want to order this. So we have the keys, and we can just run sorted on the number dictionary. This will always run on the keys, and then the values are going to be we're going to just run the number dictionary loop here on this. So for key in keys. So key in keys. So if you're not familiar with this notation here, this is list comprehension. It's very powerful. It's just a short way of writing the same as this. So for key in keys, values values append. So values has to be is an empty list, right? And then append the number dictionary value of that particular key. So instead of writing these 3 lines, I can just write list comprehension here, and values. So instead of writing these 3 lines, I can just write list comprehension and get the same thing. So now I have 2 lists, and the keys one is ordered from 1 to 9. And now I want to plot this, right? So I'm going to run plt for my matplotlib. A bar graph is what I want, and the keys are going to be the different categories, and the values are the heights of the bar graph. And then maybe I add a few other things to this graph. So this is going to be the distribution, right? So it's maybe make this a bit fancy here and say this is an f string and distribution of, and then we can use our digits variable here, which is here. From here is either all digits, trailing digits, or leading digits. Okay, and then in addition we want next label. This is just going to say digits, and then an y label, and this is going to say frequencies, and then we just want to show the plot graph, right? So instead of returning a dictionary, we're just going to plot everything now. All right, so let's rerun this what we had before. Error y label. There we go. So, all right, so this is the distribution of the trailing digits. This is the distribution of all digits. 1 and 2 here clearly in the lead, and then the distribution of only the leading digits. And now we could think about whether this matches Benford's law. But of course, at this point, we have only scraped 25 pages, and also there's still a few things we probably want to fix. So yeah, we're not going to discuss this in this video. Instead, we're going to fix some remaining issues in the code in the next video.